This next team is Streetbyter. Yes, just like Street Fighter. Except this time it's about coding and battling and becoming a better coder and developer. Let's check out how they do it.
Hello, my name is Jason, and this is Stuart, Sean, and Stott, and we are Team Streetbyter. It can be lonely practicing coding by yourself, so we created an online app where users can compete against friends in real time to solve coding problems. If you look at the screen, you'll see a demo of one user, Chun-Li, using our website. She is on the home page, which lists the questions available and is rendered in React. In the backend, questions are stored on our Postgres database. If you look, it looks like Chun-Li has received the challenge from her friend Blanca to battle. She has accepted, so now we have switched to the multiplayer battle screen, where both Chun-Li and Blanca will race to see who can be the first one to solve the problem. We've also included for you a split screen, so you can see the screens of both Blanca and Chun-Li as they do so. I will now turn to Stuart, who will describe some features available to users.
All right, so here are some of the features that are available to Blanca and Chun-Li as they write their code. Each player has a text editor to type their solution and a run button they can press to run their code. In the box on the lower right-hand corner of each screen, the player can see a scrambled version of their opponent's code. On the bottom left, we have a chat box that you can use for either giving your opponent some encouragement or some friendly trash talking. On the left side of the screen, you can see that a freeze power-up button has appeared randomly. Power-ups are designed to add a bit of spice to our coding challenges, if users wish. Now, Blanca has hit the freeze button. Chun-Li's screen will be frozen for a few seconds, which will give Blanca extra time to finish his solution. Sean will discuss more of our multiplayer features.
Okay, thank you, Stuart. So now seems like Blanca is working on two-pointer solution for this question, and he almost got the correct answer. So now he's about to run the code. Oh no, he failed, but Trinity will now with such a great opportunity, so she decided to use her power swap button to swap the code with Blanca. So now apparently Blanca's code have some bugs in there. So Trinity is working on fix those bugs. So in order for us to manage all the states in our battle game, we decided to use Redux. So now Chun-Li has fixed all the problem. So she submitted code. And yes, Chun-Li won. So for all the real-time game feature we have here, we utilize socket.io to manage all the to manage WebSocket to make connection between users and our server. So now I will turn to my teammate Scott to discuss more about code evaluation. Thank you.
Thanks, Shane. So, Blanca submits his code, but we have a problem. How do we evaluate this code safely? What if he writes something malicious that tries to abuse the memory you've allocated to him or access system processes? We need some sort of sandbox in which we can run his code, but with limited resources, which is why we decided to go with Docker. Docker allows us to easily spawn siloed disposable containers in which we run any user arbitrary code. And to make our app as robust as possible, we decided to distribute our servers across the web in classic microservice fashion, just AWS EC2 instance playing host to our sandbox container and its supervisor. All right, data flow. So what exactly happens when Blanca hits submit? As you can see in this easy to understand diagram, it's pretty obvious, right guys? Just kidding. This piece of spaghetti was our day one diagram and makes absolutely no sense. All right, for real this time. Next diagram's a little more clear. So Blanca submits his code on the client side. It gets passed to our Heroku server, bundled with some metadata, sent to our supervisor, listening on EC2, container is spun up, code is evaluated inside the container, result is piped back to our supervisor, container is disposed, supervisor sends the code back to our Heroku server, who passes it on to Blanca, awaiting on the client side. Now Blanca sees that he has failed the test, so he might want to practice some more. He can totally do so. Streetbyter allows for single player mode in addition to multiplayer. But where's the fun in that, right guys? Practicing on your own can be kind of lonely, which is why we created Streetbyter, because we believe a little friendly competition goes a long way. Thank you.
right, Corey, I'm sending you a challenge
Let's do
right
it
now.
Right now, Street.
Fire it up.
Okay. All right.
What you can't do in their app, I think, is this. You can do just about anything else. That's a really cool idea to just there.
You know, I can see this turning into a hard to get work done kind of thing.
Yeah,
so.
definitely. But a good way to procrastinate because you're learning something along the way, right?
Exactly.
And yeah, it looks like a lot of fun. They really just have a nice polished, clean experience. They thought about security of, you know, executing user-generated code on a server by containerizing it, just all around.
Yeah.
Unbelievable.
Yeah, they clearly learned a lot themselves by architecting it this way. It really keeps it from you know, any of that code from leaking out. So if you wanted to get an extra edge over your, you know, competitor, you know, try to break their system, and you just cannot do that with this architecture.
Yeah, they really thought that. I also think, you know, we see a lot of teams deploying on Heroku, which is fantastic. They ended up spawning their own AWS EC2 instances to be able to take care of this, which is really nice additional kind of ops work on their end to get this done. So really nice stuff.
So what's the next team?